Okay, so you're gonna clean the and some students just say clean with sandpaper, 0 marks. If you put clean with sandpaper, cannot, because you must tell me which part of the chain or the bicycle you are cleaning. So you say clean the rusted chain with sandpaper, correct? Okay, why? So for every point that they give, when they ask you to justify or when they ask you anything, you must explain why to it. Okay, because I want to remove the oxide layer. Okay, then if you look at the next one, again not related to chemistry, but see, this is how the answer is. Okay, you can actually apply coat or spray apply, spray or coat the paint on the frame. Some students just said spray paint or apply paint, but you never say on the frame or on the bicycle. You also don't get marks. Okay, you must be very specific when you want to answer. Okay, why? Because you want to prevent iron from being in contact with water. You can also say to prevent rusting. Again, here teachers teaching you how to answer, yeah? Some students actually went and did the whole electroplating. You electroplate, anode is this, cathode is this, all 6 marks they expected on electroplating. They only got 2 marks, okay? And then the last one, how to repair the chain? You must say spray grease or oil on the chain. This is the exact marking schema, so you'll actually get to see it, okay? All right. Anti-rust also you can put, all right? And it says so that the bicycle can move smoothly. So just a reminder, when they ask you questions like justify, when they ask you questions like explain the way to overcome the problem, okay? And if they give you 6 marks, so 3 suggestions, 3 explanation. Don't just write 6 points like that, cannot. For every suggestion that you give, you must have an explanation. Same thing goes for justify. When you want to justify, either say yes or no, or which one you choose, you explain and you give your reasoning as well. Okay, so that's one thing to look at. Okay, I wanted to start with that. Okay, so I just want you to take a photo of this. If you have time, if you can, take a photo of this. Okay, these are some things that you can focus on. I'm not saying that it's going to come out, but you can focus on. Okay, if you've done taking this one, you can take for this one as well. Okay, and if you look at it, it's like, teacher, it's almost everything that we have studied. Okay, yes, it's true. But if you don't read it, then you wouldn't know what's going to come out for exam, yeah? Okay, so we're always going to start with definition. Again, I cannot teach you all the definitions, but I have definitions here for you. You need to read up, you need to memorize them. If not, you will not be able to answer them. Okay, so this is the first part, full of definitions, all the definitions here. Okay, teacher's going to start with chapter 2. Okay, and I'm hoping that I don't have to answer the question myself. You will answer the question. Okay, so the first one here is, what graph is this? I prefer to have you all talking to teacher than me alone. Okay, what graph is this? Can I also have someone from 5B? You take the attendance for 5B. Okay, someone from 5B. Sorry?
We are putting the attendance in our group, sir.
Okay, you send it. So can someone send it over to 5A's group also as well?
Joshua, please.
Okay, you have to ask Sarah maybe.
Okay, sure, sir.
All right. Okay. Now, why doesn't the temperature change from T1 to T3? Okay, why does this remain constant? So what graph is this first? Can someone tell teacher, what graph is this? What is the name of this graph? It's a very simple name. It's literally starting with H. Okay, what does it go after that? Correct. Okay, it's a heating graph. Okay, John can change yours to for everyone to see so that you know, yeah? Okay, correct. It's a heating graph, and they like to ask this question. Naphthalene didn't come out for a long time, yeah? So teacher wants you all to take note of this. Okay, so it heat energy absorbed. Okay, heat energy absorbed here is used to overcome the forces of attraction between particles so that solid can change to a liquid. So if they give you 2 marks, 1 mark will be for this, and the second mark will be is used to overcome the forces of attraction between particles. Okay, I'm going to ask you my second question. What is the melting point? Okay, look at the graph. Look at the graph first. Give me your answers. You can type your answers in the chat. Okay, what is the melting point here? Don't be afraid to answer. Try. Okay, so a lot of you said 80 degree, 80. Okay, maybe you all didn't put the word Celsius, but yes, the answer is 80 degrees Celsius. Actually, the answer is right in front of you there, if you see it, okay? And the answer is correct, okay, 80 degrees Celsius. Okay, so some students like to answer T1 degrees Celsius, it's wrong. Some like to say T3 degrees Celsius, also wrong. Okay, it is actually 80 degrees Celsius. Okay, now, if you look at the second graph here, why does the temperature remain unchanged when liquid is changing to solid? That means terbalik already, you know. Just now liquid to solid, solid to liquid, now liquid to solid. Okay, and then the reasoning is different. And teacher wants you all to take note because it's just memory power. Okay, the heat energy loss to the surrounding is 1 mark. If you need to take a photo, teacher don't mind. Okay, it's exactly balanced by the heat energy release when particles attract each another to form solid. Okay, so we have here the second mark. Okay, some of you still can't, until today, have not memorized it yet. Okay, so teacher wants you to memorize it. Okay, take 30 seconds, teacher give you 30 seconds, take some time, look at it, memorize. Okay, then teacher will call one person to give me the answer. Sanjeev just came in, I think. Okay, all right. Who would like to volunteer? You are like, okay, teacher, I think I can do it. And Joshua's not here, yes? Somebody else has to take Joshua's place. Okay, I want to do the cooling graph. What is the explanation when the curve? Why is the curve, sorry, why is it a constant when we have a cooling graph? Who would like to try?
Sir,
Okay, Leuven, I can hear you. Yes, go.
heat energy that is lost to the surrounding
Okay,
balanced
okay, exactly balance.
by the heat energy released when the particles are attracted to each other
To form a,
to form a solid.
okay, are you looking at the answers and giving me?
No, sir, I am trying my best to memorize.
Okay, correct. The answer is correct. Okay, all right. Now this one is, teacher will go very fast. So I'm covering chapter 2 first. Okay, so this is quite easy. Okay, this is something that teacher wants you all to pay attention. Okay, highlight, take note. Okay, cobalt 60. What am I using it for? Okay, is radiotherapy for treatment of cancer. Gamma rays. Okay, it will destroy food in bacteria. Carbon 14 came out in exam before, but you should know as well. Wait, let me put in first, to estimate the age of fossils and artifacts. Okay, and the last one, phosphorus 32, your words are very important to study the metabolism of phosphorus in plants. So this is the answer for, this is the ones. Okay, now I want to ask you all this question. Is RNS an isotope?
Yes, sir.
Okay, yes, correct. Okay, why is RNS an isotope? Okay, same proton number, but what is
Different
the
nuclear number.
different nuclear number? What is the full sentence for an isotope? What is the definition of isotope? It can be anyone else. Doesn't have to be just Leuven answering. Anyone else can also put in the, okay, Krisha is coming in. Can also put in the group as well. Okay, atoms of the same element with the same number of proton but different number of neutrons. Correct. Okay, now teacher's going to ask you the next question here. Okay, probably you haven't seen this question. Between R and S, which one is radioactive? R and S, which one is radioactive? Just type the answer in the chat. It doesn't matter.
S.
Okay, who said S?
Ashwin.
Dashwin says S. Okay, next one. Anyone else?
Ashwin.
Sorry, Ashwin. Okay, so let me just put a here. Okay, Dashwin also said S. Ashwin also said S. Okay, the rest of you?
I shall go with S, Chef.
He also will go with S. Okay, Leuven also going with S. The rest of you? Okay, I want to hear from either three of them, or Dashwin or Ashwin, yeah? Leuven also. Why did you say it's S? Why can't R be radioactive? Why does it have to be S that is radioactive?
Because the normal nuclear number is 12.
Very
So-
good. Correct. That's the perfect answer. Okay, the normal nuclear number is 12. Therefore, we are not going to choose carbon 12. Okay, whatever it is, you can never choose the one that is radioactive when it is the normal one, the one you can find in the periodic table. The one that you can find in the periodic table, it is not radioactive. The one that is not in the periodic table, that is the one that is radioactive. Okay, please take note of that. So correct, S is the one that is radioactive. Shamira coming in. Shreya is coming in. Okay, now let's look at this question. This one is a naphthalene question. Okay, teacher, give you 30 seconds to try this question. Nakia and Kavi, as I am calling out the names, you minus off, yeah? Farah, can you call I know? Ras is also not here. Can someone get Ras? Okay, Ras Panjang Umur, she's coming in. Okay, I hope by the end of this lesson, yeah, not by the end, it's very soon, all of y'all will come in. Okay, let's try this question. Okay, I'm determining the melting point of substance L. Okay, substance L is a white solid. You have done this experiment before. What is substance L? What do you think is substance L? You have done this in the lab before, the exact same way. You're not sure.
Sir, I don't know, sir.
Okay, Leuven don't know. How about the rest of you? Okay, what is substance L? And you know that it's melting at 81 degrees Celsius. So it's actually, Ryan is coming in. Okay, and it's not very high temperature. Okay, so what do you think is very good? Okay, John says it is naphthalene. Okay, I don't know whether I gave the answer just now. Okay, naphthalene. Okay, now, if I don't use naphthalene, actually there's another thing that you can use. If teacher doesn't use naphthalene, what else is it that I can use? One more thing that is very similar to naphthalene. What is it?
Phenolphthalein.
No, phenolphthalein is not at all. So it came out in exam before. Sometimes they don't use naphthalene, they actually use acetylene. Same properties, very similar as well. Okay, so the answer here anyway is naphthalene. Can you all draw for teacher the arrangement of particles of L at 60 degrees Celsius? Okay, what is the arrangement of particles of substance L at 60 degrees Celsius? Okay, let's do this together. What is the state at 60 degrees Celsius? Is it a solid? Is it a liquid? Is it a gas? Akil Amin is coming in. Okay, John says solid, but how many of you don't know? If you don't know, just put in the group, I don't know. Quickly, yeah, so we don't waste time. Teacher also want to go faster a bit. I know is coming in. You have to communicate with teacher, then only I'm able to help you. Oh, solid. Okay, John says solid, but the rest of you, what else what is your answer? Hi, Akil. Quickly. What is my, at 60 degrees Celsius, what is it? If you don't know, just put in the group, teacher, I don't know. Teacher, macam, okay, very good. Okay, good. Some of you don't want to put it in, some of them don't know it's solid. Okay, now everyone draw the line together with teacher, okay? Draw the line together with teacher. So I know at 81 degrees Celsius, okay, it is changing from solid to liquid. Okay, so this is my melting point. Okay, then I find out where is my 60. 81 is here, therefore 60 is here. Now if 60 is here, what is the state? I'm hoping that you all will answer with teacher. What is my state at 60? Look at this.
Solid.
Yes, solid. Okay. Very good. Okay, it is solid. All right, good. So now teacher is going to draw how to draw a solid. Okay, so we don't waste time. I'm going to teach you. All you have to do is 3 times 5. Now you can do a box in a box. It doesn't matter if you want to do a box in a box or not. Yeah. So 1, 2, 3, 4, 5. Now this one you have a choice to do like this. Okay, and then here you want to end it like that. Okay, and then here you can do this again. But you must make sure there's no empty spaces whatsoever, because even teacher, I'm a very strict marker. Okay, cannot be different size, cannot be, everything must be very, very close to one another. Okay, for like this, teacher will accept. Okay, I'll give you 1 mark. Okay, now next question. Why does substance L has a melting point of 81 degrees Celsius? Okay, why substance L has the melting point of 81 degrees Celsius. 81 degrees Celsius, is it a high melting point or low boiling point? Quick, quick, quick. High, is it high or low?
Low.
Very good, very low. Okay, now when something has low melting point, very good. Work together with teacher. Even as I'm doing, you are writing there. Okay, I want to see everyone writing together as well. When it's a low melting point, okay, what are my forces of attraction?
Weak van der Waals forces.
Very good. It's weak van der Waals forces of attraction. Okay, FOA, yeah. So when it's weak van der Waals forces of attraction, do I need a lot of heat energy or a little heat energy to overcome the forces of attraction? Very good. Okay, a little. I want to see if you cannot type. I'm sorry, if you cannot say out, I want to see you typing. At least I will know that you are also in the class together with teacher. A little heat energy is needed to overcome the forces of attraction. Okay, all right. Okay, do you all get this question? So point number 1, substance L is held together by weak van der Waals forces of attraction. Okay, therefore a little heat energy is needed to overcome the forces of attraction. Nakia, can you do the attendance again, Nakia, from the names that teacher mentioned? Okay, she has. I keep telling. Okay, Kritika get Adi. Krisha is already in. Sam get Lavi. Ideal, can you get Akil and Azim? Amani, can you get Faizan? Shamira is also in. Teacher will try to call Sarvesh. Ashwin, can you get Treshan and Tena? Again. Thank you. And can I have Dash getting Havi? Thank you. 5B, I can't help you, yeah, because I don't know what's your list like. Okay, but because I prepared a lot for y'all and I don't want it to go to waste. Okay.
It's okay, sir. I'll try my best to call everyone, sir.
Thank you. Thank you so much. So you can pass the attendance over here later, yeah? Okay, so this is just a bit of the questions that I prepared for chapter 2. Okay, we move on to chapter. Okay, this one is another question, and I'm going to give you a question later on. Okay, let's look at this. This is a calculation question. I'm going to teach first for the sake of some people who still don't get it, and later you're going to do it on your own. The scale in the boiler has 50 grams of calcium carbonate. What's another name for calcium carbonate?
Limestone.
Very good. What's another name for limestone? Not another name, sorry. What else has calcium carbonate in it? What in our daily lives has limestone? This question y'all don't have, yeah? It's only on my slide. So, but never mind, y'all can write as you are. I'm doing some questions. So if not, yeah, it's fine. What's another? Yes, very good. Very, very good. It's eggshell. Okay. So later you will understand why I'm asking you this question. So write a chemical equation between calcium carbonate and hydrochloric acid is no-brainer. Okay, it's a no-brainer question here. Oops. It's calcium carbonate plus 2HCl, CaCl2, I get H2O plus carbon dioxide. Sarvesh is coming in. It's a miracle. Sarvesh is here, okay? All right, now teacher wants you to do the question for teacher. Okay, what is the volume of carbon dioxide produced when I add excess hydrochloric acid to it? Okay, so I've got 50 grams of calcium carbonate. What is my volume of carbon dioxide here? Teacher is not showing you the answer. Okay, you have to try for teacher now. You've got the equation. The equation is calcium carbonate plus 2HCl, arrow CaCl2 plus H2O plus carbon plus water. You got 50 grams of calcium carbonate. What is my volume of carbon dioxide gas? Okay, teacher give you 30 seconds to answer the question. You can answer it now.
What's the chemical equation again?
Calcium carbonate plus 2HCl, arrow CaCl2 plus H2O plus carbon dioxide gas. Is today Joshua's birthday?
Yes, Chair.
Tomorrow, Chair, tomorrow.
No, Chair, today is the day. 6.
Today, right?
Yes, sir.
Yes, Chair.
Okay. All right. Yeah.
I thought the 8th.
Joshua, wait. I will wish you, Joshua, wait.
He's not here. He's not here. That's why he went
Okay,
for his
thank God.
birthday dinner.
Thank God, Chair.
That means you no one wished him, is it?
Chair, I totally forgot, Chair. Biology.
Okay, never mind. All right, it's okay. Okay. Who can try the question for teacher? What's my number of moles? Don't be afraid. Come on, try it out. Okay, good. Austin says 0.5 moles. Let's go and check whether Austin is correct. Okay, and of course it's correct, okay? And one thing that I want to remind you, I love calcium carbonate. Why? Because calcium carbonate, the RMM is 100, forever 100. Okay, iPhone is coming in. I don't know who that iPhone is. Okay, later Nakia go and check him out, check him or her out. I don't know who's that. Okay, so 0.5 more. Okay, next step, I want someone to say it out loud for teacher. The answer is in front of you, but I want you to read out the ratio for teacher. Anyone who's willing to try. Okay, Adi's not picking up the phone. All right, carry on. Who wants to read for teacher the ratio now?
Is it 1 mole of calcium carbonate to 1?
Correct. So 1 mole of calcium carbonate gives me 1 mole of carbon dioxide. Therefore, if I've got 0.5 more, my second sentence.
0.5 moles, 0.5.
Yeah. So the next one will be 0.5 mole of calcium carbonate produces 0.5 mole of carbon dioxide. Can I miss out? Can I omit the mole? Can I omit the mole? Can I don't want not to write the mole?
Cannot mesti ada.
Yes, you must have the mole. If you don't write the mole, it's wrong. Okay, good, correct. Okay, and you end with 0.5 times with your molar volume. Okay, and that will be your answer, correct? 12 decimeter cube is correct. Okay, so I think you know how to do this. I would like you to do this for teacher. Adi is coming in. Sarvesh already in, Nakia. Someone with iPhone also is in, but I don't know who's that someone with iPhone. The person with iPhone, who are you? Okay, Nak, never mind, Nak. You do the question. Thank you for helping, teacher. Whoever's in the class, if you came in with iPhone and your name is still there, teacher would like you to let us know, yeah? iPhone, you're on my screen. Who are you? Trishan is coming.
Sorry. It's me, Shadat.
Hi, Shadat.
Hi.
Madhavan is coming in. Okay. All right, then. Have you all finished the question? Who's that? Okay, Adi is coming in again. Okay, what's my first balance equation? That's very simple, very easy. What's the first balance equation here? You're using eggshell, you're using vinegar. Okay, so slightly different, slightly different. So what is the equation here? Be brave to try. If you don't try now, you never know.
Is it CaCO3 plus
Okay.
CH3?
CaCO3 plus,
CH3COH.
okay, correct, CH3COOH. Okay, I'm going to pause at you. I'm going to call, who should I call? Let me call Lee. Okay, Lee, try. Okay, what's my side product first? To make it easy, try teacher's side product. What's the side product here? Correct. Okay, I've got CO2. I've got H2O. Okay, excellent. So we know that my CO2 is out, okay, from here. All right, and my H2O also out. Okay, so we need to balance this. Okay, how do we balance it and how do we write the equation now? Okay, so let me help you all. It will be CH3COO bracket 2 Ca. Okay, so here teacher will have 2 here in front. Okay, so this will be your equation. I want you to double check now. Correct or not your equation? Correct now. Is it balanced or not? Check and see, is it balanced or not? Do you have everything in order? Are you all not sure? Okay, some of you all don't know how you get this product. Okay, this is a bit difficult product, but you actually learn this in carboxylic acid. Okay, carboxylic acid, when it reacts with magnesium carbonate, okay, or any metal carbonate, you will get this. Okay, why did teacher have to get this? If teacher actually just use a normal one, for example, HCl, okay, the calcium went to the Cl and then the H went to the carbonate. Okay, but for this one, you are going to get a different product because this is ethanoate here, calcium ethanoate ready. Okay, a different product altogether, but doesn't matter. Even if you blunder in this one, it doesn't matter. We look at the next question. Okay, we look at the next question, which is what is the mass of eggshells to be prepared and to react with the vinegar to obtain the maximum gas. Okay, now we know that my maximum gas here is 4,800. Okay, and then you know my number of moles here is 1. Okay, what's my first step? How can teacher find number of moles of the carbon dioxide gas here? What information given to teacher?
Volume of gas.
Very good. What's my volume of gas given?
4,800.
Very good. 4,800. What is my molar volume?
CO2, right?
24,000. Very good. Okay, so 48,000 over 24,000, what do you get? $4,800 divided by 24,000. You get 0.2 mole. Okay, can everyone concur that all of you got 0.2 mole? Perfect. Very good. So you see, even if they change the substance a bit, it doesn't matter. You're still okay. Okay, next one. They asked me to get mass of eggshells. So I now need to relate your number of moles of carbon dioxide to your number of moles of calcium carbonate. Who would like to do that for teacher? You can say it out loud so it's faster. 1 mole of CO2. Okay, 1 mole of CO2 will give me correct. 1 mole of CaCO3. Very good. 5B students also can also put in the chat. Yeah, teacher would like to hear from you all as well. So at least I know you understand. Okay, 1 more gives me 1 more. Therefore, the next step. You're really shy people, huh? Okay, so
0.02 mole.
0.2 more carbon dioxide will give me
0.2.
0. Okay, 0.2 more calcium carbonate. I told you calcium carbonate is your best friend because why? What is the mass relative molecular mass of calcium carbonate? 100. Very good. Okay, so right now what you're going to do is you are going to then carry on 0. You want to find the mass, and the mass is equals to number of moles. Very good. Very good. All of you are following well. Maybe what you can do is stop sending it just to teacher. Send it to everyone in the group so they also can see your work. Yeah. Number of moles times molar mass. It is 0.2 times 100. What's my answer, class? Wrong. Correct. 20 grams is correct. Well done. Okay. So the twist of the question a little bit, but you're still able to answer the question. Okay. Now let's go on to the next question. Okay, you don't have it there with you. It's only with me. Don't know if you have done this before. Okay. Definition of molecular formula. Again, Joshua's not here. Okay. So someone has to help him to answer. What's the definition of molecular formula? Exam on Wednesday, you know.
Okay.
I can hear someone saying something.
The chemical formula that shows the actual number of each element of each atom in the compound.
Okay, you are almost there. No need to say each atom. Okay, just atom will be correct. Say it again, Amani.
Chemical formula that shows the actual number of atoms of each element in the compound.
Okay, very good. Yeah, his answer is correct. Well done there. Okay, what's the empirical formula for ethane, class? What is the empirical formula of ethane? Empirical formula means simplest ratio. And this is my ethane up here. What's my empirical formula here? Very good. Very good. Excellent, children. Yeah. CH3. Okay. Now you're getting the groove ready. Yeah. Very good. What's the physical state of ethane? This is memorization. It's in the textbook. What's my physical state of ethane? Okay. Yes. So the first four, methane, ethane, propane, and butane. Okay. They're all gases. Okay. This one you must go back. You must read. Okay. It's correct. It is a gas. Okay. Good job, Madhavan there. Yeah. All right. So let's move on here. They're asking you what is the value of x here. So sometimes, okay, let's do this. What's the value of x here? Count. If you don't know how to count, also put it in the group. Teacher, I don't know. Put it in the chat so I can teach. Because I'm assuming by now everybody knows. Okay, if you don't know, just say, teacher, I don't know. Just put in the group. Don't care. Or you can PM teacher personally also. If you don't know. Okay, some of you did not answer. Why? Okay, I see 3 people only answering. The rest of you didn't answer because you don't know.
Is it
Is it what, Nick? Okay, there's a pause there. So never mind. Just for the sake of everyone, I only see 3 people getting 7. So let me just show. So normally teacher will always not have a 2 in front, right? But this particular question has a 2 in front. Okay, that means to say that you have to times everything first. So here I got 2. 2 times 2 is 4. So I got 4 carbons. So that's why teacher put 4 carbons here. Okay, same thing for the hydrogens. I got 6 hydrogens here. I times with 2, I get 12. So here teacher got 12 hydrogens here. Now we balance off the oxygens. Okay, teacher got 6 here. Teacher got 8 here. 6 plus 8 is 14. Okay, how to make over here 14? So teacher put 7 over here. It's actually very similar. Okay, no difference from the usual. Okay, again, the calculation question that teacher wants you to try. Okay, so you got the equation ready. Faris has carried out the complete combustion of ethane. What is the volume of ethane to produce 1.1 gram of carbon dioxide? Okay, at standard condition, temperature and pressure. Okay, so the equation there says 2C2H6, okay, plus 7O2, arrow, you are going to get 4CO2 plus, what's this now? 6H2O. Okay, everyone try with teacher. What's my answer here? I want to find out what is the volume of ethane. Okay, what is my volume of ethane here? Okay, what is step number 1? Faizan is coming in.
relating?
Sir, can I
Yeah.
find the... Sorry.
What? It's
Is it
relating.
Relating, yeah.
But before you relate, you must find something else. So always calculation got 3
Number of
steps.
mole.
Correct. Okay, Yannick, since you are saying it first, you go ahead. What number of mole are we finding for? Now we are calculating number of moles of carbon dioxide, correct?
Yes, sir.
Okay, what is it?
Is it 1.1 over molar mass?
Correct. What's the molar mass of carbon dioxide? Again, carbon dioxide must be your best friend. Carbon dioxide's molar mass is 44. Okay, so 1.1 divided by 44. Everyone together with Yannick calculating and putting the answer in the group, in the chat.
0.0 mole.
Okay, correct. Okay, 0.025 mole. Okay, I'm hoping the rest are trying as well, yeah? And I can hear their response as well. Okay, so 0.025 mole is correct. What's my next step? Okay, Yannick mentioned it, but I want somebody else to say it. I want somebody else to try. Because this is the second time already we are doing a calculation question. Okay, yes, good. Go ahead, Leuven.
2 moles of ethane is equivalent to 4 moles of carbon dioxide.
Okay, and then?
So, wait, just give me a moment. So, 0.0.
Okay, go on.
0.0125 mole of ethane
Very good.
is
Gives you?
equivalent to 0.01 0.025 mole of carbon dioxide.
Correct. Very good. Okay. Good, Yannick. Good, Lugan. Okay, another person. Finish this for teacher. You already know this already. You've gotten your ethane ready. What's the next step? Quick. Faster, then teacher can go on faster. Quick, quick, quick.
Times with the molar volume.
Okay, good. Okay, so 0.025 times, what is my molar volume bin?
22.4.
Okay, 22.4, and therefore my answer will be?
Zero point two
Five.
dm
Okay,
cube.
but if they're asking you in centimeter cube? Okay, correct. All of you are not wrong. Okay, you put 0.28, no problem. Okay, but I want to let you know that if you want to put centimeter cube, also can. So 280 centimeter cube. Well done. All of you are doing very well. Good job. Somebody got 0.24. Okay, please go and check. Did you get 0.24 because you did not use 22.4? Must always refer to the question. Okay, so this is the answer. Okay, so for this part, okay, I've done chapter 2, chapter 3, now going to chapter 4. Now, saya dah faham teacher always give. Always teach you saya dah faham. So I'm just going to very quickly, briefly run through with you. Okay, if you're comparing Y and we're comparing X, we can see already saya is size, okay? So the atomic size of Y, atom, remember the keyword is atom. You want to snap photo, you go ahead, it's slides anyway. I'll pass all the slides to you all later, is larger than X atom. Point number 1. Okay, so saya, size. Okay, and then if this question is, when you're going down group 1, okay, what is the reactivity like? So point is the reactivity going down group 1 increases. And this is the reason why. Okay, because number 1, the atomic size is larger of Y than of X. The distance between the nucleus and valence electron, if you don't have nucleus and valence electron, no marks. Between Y atom is further than X atom. Okay, because you all are so clever, what's my third and fourth point? Saya, I've done for you. Da, I've done for you. What's the F? Yeah, I can hear someone whispering. Someone whispered forces of attraction. But no one brave enough to say it out loud. Quickly. After this, I'm going to group 17. I'm going to ask you the same thing.
Forces of attraction between valence electron and nucleus.
In atom Y.
In atom Y is stronger than
Atom X. Let's say lah. Sanjeev, are you continuing?
no, sir.
Okay, all right. Yeah, so what he said was correct. Okay, the forces of attraction between between nucleus and valence electron. Did you say stronger or weaker?
Stronger.
Okay, so if you are going down the group, then it becomes weaker. So that means he was saying terbalik. Yeah, so Y atom is weaker than X atom. Going down the group, your forces of attraction becomes weaker. Okay, when you're nearer to the nucleus, your force of attraction becomes stronger. Okay, so when you know that, okay, what is your last part? Okay, Y atom can donate its valence electron more easily compared to X atom. Okay, just want to do this one more time. I will choose 4 different people. If you are here, you kenal lah. If you're not here, lucky you. Let me look at my participant. Okay, I'll start with 5B. 5B, teacher will choose Patricia, Hanin. Okay, Hanin number 1. What's my reactivity going down group 1? Let's say we are doing the same thing lah, X and Y. Yeah? One is 2.8.1, one is 2.8.8.1. Okay, Hanin, what's my first point?
Sorry, teacher, what?
Did you listen to what teacher said just now?
A bit. Wait.
Okay, never mind. I'll skip you. I'll give someone else, okay? I will
Okay.
pass on to another person. Okay, let's try Vaishnavi. Okay, Vaishnavi, if you were paying attention and you can answer, teacher. Compare with me, let's say atom X. Okay, let me do it here. Atom X, has 2.8.1 and atom Y got 2.8.8.1. Which one is more reactive? A 5 marks question. Which one is more reactive, Vaishnavi? Okay, maybe she will put in the chat, I'm not sure. Okay, it doesn't matter. Teacher will move on then now to 5A then. Teacher will go to Iman. Which one is more reactive, Iman?
2.8.8.1.
X or Y?
Y.
Very good. Okay, atom Y is more reactive than atom X. 1 mark, correct. Okay, next person. Kavi, Y. Saya dah faham A. Give me 2 points. Kavi didn't ask anyone to cover for him. Okay, Kavi's not here. Anyone want to help Kavi? Adi. Okay,
Atomic size.
sorry, go ahead.
Atomic size of 5 atoms is bigger than atom
X.
X.
Correct. Okay, that's my first point. Second point.
Distance between the nucleus and the electron or atom with it. Right?
I have to strain to hear you, Yannick. So teacher really can't hear, but your answer is correct. Okay, the distance between the nucleus and valence electron in atom Y is further than atom X. Correct. Yeah. Okay. Next one, Madhavan. Third point. Madhavan also not here.
He typed so long. Sir.
Okay, the Madhavan doesn't have the point that I want. Okay, never mind, Madhavan. You try typing for the other two as well, yeah? Adi, what's my next point, Adi? I'm just doing this so that I know who's actually here and who isn't, okay? Adi, what's my next point, Adi?
Forces of attraction.
Yes, it is, Luvan. Okay, I can see that you're waiting to answer. Okay, Luvan, I'll pick you.
I wasn't waiting to answer. Back up.
Okay, Luvan, go ahead.
Forces of attraction between the electrons and the nucleus in Y is weaker than X.
Okay, class, you tell me his answer is correct or not?
Wrong.
Thank you, Win. Appreciate it.
Is his answer correct, class?
Sure. Wait. Sure. Okay, understand. Kritika Akka. Okay. Fine. See, everyone attacking me, so thanks.
Okay, yes. You just missed one thing.
Yes, X atom is weaker than Y atom, sir.
Very good. And we'll just end it, okay, by calling Russ. Russ, end it for teacher.
It is easier for atom Y to donate its valence electron compared to atom X.
Okay, perfect. Okay, so you all got the answer here. Okay, 5B teacher would love to call you, okay, but I don't know who is here and who's not. If you are here, maybe you can put in the chat so teacher will be able to call you, okay? It's not that I don't want to call you, but I don't know whether you are here or not. Okay, again, I'm going to go faster a bit because my aim is chapter 6, 7, yeah? So here is group 17. If group 1 going down the group, the reactivity is increasing. Group 17 going down the group, the reactivity decreases, but all the points are the same, okay? The reactivity means fluorine on top is more reactive compared to the rest, okay? Now let's see why. Okay, so here I've got 2.7 and then 2.8.7. Okay, so what's my point? Compare the reactivity here. Element Anis Chomel is coming in. Element P is more reactive than element Q. Okay, so this part you put the word element is still fine because we're not talking about the atom yet. Okay, element P is more reactive than element Q, correct? Because the size is smaller. So we can say the atomic size of atom P is smaller than atom Q. Perfect. Same point again, distance. The distance between the nucleus and the valence electron for atom P is closer or nearer than atom Q. Perfect, perfect. Same point. Force of attraction between nucleus and valence electron is stronger for atom P compared to atom Q because atom P is smaller. But look at the last point. And the last point is the one that is different. In group 17, the easier for me to receive electron, I am more reactive. Write it down in front of you, a paper in front of you, what teacher don't care. In group 1, the more easily for me to donate electron, I'm reactive. In group 17, the more easily for me to reach, or the higher tendency to receive electron, I am more reactive. So here, atom P has a higher tendency to receive electron compared to atom Q. Okay, that's why going down group 17, the reactivity will decrease. Okay, that is reactivities. Okay, again, because teacher think it is very simple, I am not going to go on further. Okay, now let's talk about size across the period, because this question also always come out. Okay, why is there explain the change in the atomic size in table 1. If you look at the atomic size, sodium is very big and then chlorine is smaller. And I've given the example before of Milo. The more Milos you drink, you become stronger. When you become stronger, you're able to pull the electrons closer towards you. Okay, so point, if you got 4 marks here, how are your marks like? The atomic radius will decrease across the period. Okay, correct. From left to right, my atomic radius is decreasing. Why? Number 1, I have increase in the proton number. If you notice properly, my teacher's proton number here is increasing from 11 to 12 to 13 to 14, 15, 16, 17. Okay, so the proton number increases. Okay, even if you didn't say the word positive charge, it doesn't matter. Okay, proton number increases, point number 1. Okay, when your proton number increases, therefore, when you drink more Milo, okay, when you drink more Milo, you're stronger. So the force of attraction between the nucleus and the valence electron becomes stronger. Okay, let me, for example, here I got 17 cups of Milo. Here I got 11 cups of Milo. The person that drank 17 cups of Milo is stronger. So when it's stronger, it's able to pull the electron closer towards the nucleus. When I'm able to pull it closer towards the nucleus, my size becomes smaller. Okay, so that's the explanation. Okay, it's very similar to electronegativity as well. So all these teacher will pass on to you later, you all can read up. Okay, this is some of the hard parts here, okay? Teacher's teaching, yeah, then later we do question, okay? I'm just recapping. That means what I'm doing is, I'm just giving you a bit of each chapter. You still have to go back and do the hard work of studying. Okay, I'm just going each chapter a little bit. I'm giving you questions a little bit. Then you burn the midnight all to study. Okay, look at ammonia. How do you know? Teacher, why is it a covalent bond? I want someone to answer me here. Ammonia here, why is it covalent bonding? Who can tell, teacher?
Non-metal and non-metal.
Okay, very good. I got non-metal and non-metal. Nick is correct. Okay, very good. What else? What else do you see? Non-metal, non-metal. What else? Good answer, Yannick. What else? Anyone else? What are the electrons doing? Very good. Okay, the electrons are being shared. Okay, whenever I see electrons being shared, okay, they very good, Sarisha. Okay, they are equivalent compound. Okay, so let's see. The question is asking how can ammonia or covalent compound being formed? Okay, so it's very simple. 3 hydrogen atoms are sharing a pair of electron with nitrogen atom. So here I've got 3 hydrogens, 1, 2, 3, 3 hydrogen atoms sharing a pair of electron with nitrogen atom. Correct. See, they're all paired up here. Okay. Then who's donating what? Okay, so 1 nitrogen atom, they are contributing 3 electrons. Let's check. Okay, this nitrogen is the cross, right? I got 1, I got 2, I got 3. Okay, so 1 nitrogen atom contribute 3. How about the hydrogen atoms? How many electrons is it contributing? The 3 hydrogen atoms contribute how much?
One nitrogen atom, sure.
If 1 hydrogen atom, they are contributing 1 each. Okay, good. So Einol says 1 each is correct. So that means 3 hydrogen atoms, they are contributing 3 hydrogen 3 electrons. Okay, Luvan, if you say 1, that means you're talking about 1 hydrogen atom only. Okay, so covalent bond didn't come out last year. Ionic bond came out last year. Okay, so must take note. Can come out covalent also as well. So be prepared. Okay, so how do I get sodium ion and chloride ion? How is it being formed? Okay, so we know that sodium atom here is donating 1 electron and I get Na plus. And then chlorine atom receives another electron to form chloride ion. Okay, so this is ionic bonding, which I think is much more simpler. Let's look at hydrogen bond. Okay, hydrogen bond must always be bonded to what and who? Hydrogen, when you want to have hydrogen bonding, what must it have? Very good, phone. Okay, it must have phone. Okay, so first of all, you must remember that one hydrogen must also be bonded to either phone. Okay, and then when it is bonded to another molecule, this one also must be another phone as well. Okay, on both sides. Okay, it must have phone. So look at the sentence. Attraction forces between hydrogen atom that has bonded with an atom of high electronegativity, such as phone, with another phone from another molecule. So another molecule, in its own molecule, it must have phone, hydrogen and phone, and then hydrogen with phone in another molecule as well. Okay, so that day we did the question, is ammonia soluble in water? Okay, and many of you thought, oh, it's a covalent bonding, so therefore not soluble in water, and actually it's wrong. Okay, ammonia can be soluble in water because it can form a hydrogen bond. Okay, so you must take care, be careful when you're doing these questions. A dative bond, okay, how do you get a dative bond? Okay, you must make sure that you must have a lone pair electron. Okay, so there's one lone pair electron here, and H plus here has no electrons at all. So here it will come and form a bond, a dative bond with the lone pair of electron. It must have lone pair of electron, then only it can form a dative bond. Okay, so that is the 4 bonds that we have. Okay, I think this one you all should know. I want you to try the question that teacher have here. I think I've got 2 questions here for you. Okay, we do it together. Question number 1, what is the number of neutron for element T? Very good. Okay, the answer is 0. Okay, the number of neutron is 0. All of you got 0? Do you understand why you got 0 there? Did everyone get 0 for T?
Yeah, sir.
Yes,
Got
Okay, good. All right, so let's go on to the next one. Okay, what is the electron arrangement for atom Q? Okay, perfect. 2.6. Okay, next one. Okay, all of you getting the answer. What's the electron arrangement when T reacts with Q? T reacts with Q and I get a compound. Okay, tell teacher, is this a covalent compound or is it what kind of bond is this? Covalent bond or ionic bond?
Covalent.
Okay, very good. It is a covalent bond. So I'm going to answer this straight away. Now, why is it a covalent bond? How do you know it's a covalent bond?
Non-metal and non.
Okay, non-metal and non-metal. I want everyone drawing it for teacher here, please. Okay, or you tell teacher how to draw. How do I draw this? How many T do I have? How many Qs do I have?
6 Q. Sorry, 1 Q.
1Q, Q, 2T. Wow, what is 1Q
1 Q
and
2 T.
correct. Okay, now very good lah. So I think all of you should know 1Q, 2T. Okay, let us do the answer here. So how are you going to draw this? What's in the middle? What's going to be in the middle? Very good, Q. All of you drawing together with teacher, my Q must have a nucleus. And I have got 1, 2, 3, 4. Oh, sorry, I forgot one more. 2.6, 1, 2. Okay, 3, 4, 5, 6. And then teacher has T here and teacher has T here. Nucleus, nucleus. Okay, and then a bit chacat lah, teacher, sorry. But you have a 1 here, a bit chacat here, you have 1 here. Okay, sorry, don't draw like this in exam. You all draw proportionately, okay? And get you want to check whether your answer is correct, you must check whether you've drawn it correctly. T, do I have a stable duplet electron arrangement? Yes, correct. The other T also, I have a stable duplet electron arrangement. Okay, now like everyone look at Q. Do I have a stable octet electron arrangement here? Only the outermost shell, yeah? Okay, yes, my answer is correct. You have done it correctly. Okay, what is the type of particle in this compound? In a covalent compound, what's my type of particle? Okay, perfect. It is a molecule. Very good. Okay, we go to the next question. This is actually a JUJ question. Which element is a metal? Okay, John says Z. The rest of you? Okay, good. What is the meaning of delocalized electron? Teacher kenakan you already. I know. How many of you knows the definition of delocalized electron? Okay. Haven't found the answer yet, right? Who memorized? Electrons that move freely, okay, but it's incomplete. Very good, yeah? So electron that move freely, yes, half of the answer. Okay, electrons that move freely, no. Okay, so that's already only part of the answer. Good job. In the sea of electron, no. Okay, and isn't owned, continue my sentence here, and isn't owned by any atom or ion. You can open up the textbook and find the answer. It is there. Okay, correct. Okay, Austin there. Okay, so this is the correct answer for delocalized electron. So you don't know what they can ask you. They can ask you for definition of cosmetic. They can ask you for anything. Okay, next one. What is the charge form at the metal ion when valence electron is delocalized? What is the charge form? Okay, so John says 3+. Okay, so yes, you can actually put 3+, or you can actually just put a positive charge. Okay, so because he put +3 is correct. So in case some of you don't know what's going on, so it's 13, right? So it's actually aluminium. So when I am undergoing to get a metallic bond, teacher will get Al3+ plus 3 electrons. Okay, so this is the charge that's been formed here. Okay, now X and Y reacts to form a compound. Okay, X and Y reacts to form a compound. What compound is that? Again, you see already, you should know the answer. Okay, X and Y. Covalent is correct. Okay, so as I said, very good. As I said, this is just to jog your memory. I cannot do a lot. I cannot give you all the questions. Okay, but I can help you to try. Yeah. Okay. Which period are these elements placed? Very good. Period 3, obviously. Yeah. Why? Why is it period 3? Okay, good. It is 3 shells filled with electron. You cannot say 3 shells there. It's 3 shells filled with electron. 3 shells is wrong. Okay. Now, which element exists as a diatomic molecule? Okay, which element exists as a diatomic molecule? Okay, John says chlorine. How about the rest of you? Wrong. Magnesium is not diatomic molecule. Chlorine is correct, yeah? Lee, why did you say magnesium, Lee? Okay, no. All right, so always diatomic molecule is in group 17. All right, okay, I think this one we can try on our own later. Okay, great. Teachers going to chapter 6, chapter 7. Okay, yeah. Very, very important. I want you to take a picture of this if you can. Teacher will go briefly with you, do some questions here as well. Okay, so I've got hydrogen molecule gas. Okay, sorry, hydrogen molecule gas. Oops, I think you can't see this, never mind. Okay, and if I am hydrogen chloride gas, which is a molecule, If it's in water, I can ionize. Okay. Why can I ionize? Because I've got hydrogen ions present and therefore I can show my acidic property. Look at the flow teacher is showing you. Yeah, this is how the marking scheme answer should be. If my hydrogen chloride is in any organic solvent like propanol or methyl benzene, whatever, it does not ionize in any organic solvent. Point. I got no hydrogen ions, or you can say exists as a neutral molecule. Therefore, I cannot show any acidic property. This is the flow. If you want to answer the question, the flow must be there. Same thing. If I'm using ammonia gas in water, I can ionize in water and hydroxide ions are present. Okay, therefore, it shows its alkaline properties. In organic solvent, it does not ionize in organic solvent. No hydroxide ions are present. I cannot show it alkaline properties. Okay, so last year, oxalic acid came out. Okay, and oxalic acid like so weird. Okay, but you should know it's can answer or cannot answer. So let's look at this question. I'm going to show you a lot of the answers, and then later you're going to try one question on your own. So for 7 marks, okay, I've got magnesium chloride, and one has bubble of gas, one has no bubble of gas. Class, without even looking at the answer, you tell me the answer. What should be X, my solvent, and what should be Y, my solvent? If I've got a reaction, what solvent should it be? Solvent only divided into 2.
Water.
Correct. Water. Water for which one?
X.
Water is X and organic solvent is Y. Okay, correct. Okay, now I want you to look at the marking scheme, and if you want to take a picture, teacher don't mind completely. Okay, see how they answer. Okay, why do they say water? Okay, so because observation already given. So when observation is already given, listen, yeah, to how teachers teaching you how to explain. Therefore, you explain your observation. So then this is your inference. You explain that actually that bubbles of gas is actually hydrogen gas. Okay, and then you go on to the next one. You explain, okay, you explain your inference. Why you can get that hydrogen gas? Because HCl ionizes in water to produce hydrogen ions. Okay, last point, it shows your acidic properties. And on the other side, is this completely opposite? Okay, there's no hydrogen gas produced. It does not ionize, therefore no hydrogen ions. It exists as a neutral molecule, cannot show the acidic properties at all. Okay, so this is one example. Okay, this example you did with teacher that day in school, I think, if I'm not mistaken. Okay, you tell me, class, what do you think will be my solvent X here? Look, where's the reaction happening? What's not the reaction not happening? Okay, so I want you to write down for teacher. Okay, you write down and then later you check your answers, yeah? What is your solvent X? And then what is your solvent Y? You writing down your answer. Okay, once you have done that answer, teacher wants you to now explain the difference in the observation. Explain to me why set 1. Okay, I've got this kind of observation. Why set 2? I've got a different, why set 1? I've got 2 different observations. Why set 2? I've got 2 different observations. Okay, teacher want to use the same format I taught you. Okay, and I want to hear your answers after this. So it's 8 marks. So you see 7 marks, 8 marks. The marks doesn't vary at all. Okay. You try to write down your answers. Wednesday, you will be the one writing the answers, not teacher. Okay. Done? If you're done, maybe can teacher just give 1 minute, okay? Just very fast 1 minute for you to answer the question. The answers are just what we have done just now. Except that maybe for set 1, you cannot say shows its acidic property. You must mention that the bulb is being light up for the first one, and the second one bulb does not light up. Okay. One person who wants to try. What will be your first answer? What is my solvent X? Anyone in this group would like to try. Even if you type it, teacher will accept. What is X? What is Y?
Oh, X
X is
water.
water, Y is
Okay, X is water. Y is okay, choose one organic
metal
solvent that you
benzene.
methyl benzene can, propanol can, all also that you like can, okay? So very good. Okay, so you all got that part correct already, okay? So here you go. Water, methyl benzene, propanol, all these accepted. Okay, so let me just give you the answers so we do not waste time, okay? So double check your answers. The first one, what's your observation? When they say explain the differences in the observation, the first thing you must do is you must tell what's the observation lah, because they didn't tell you. So point number one, bulb lights up. The other one, bulb does not light up. Then it's the same thing but again. Ayat dia ulang. Okay. HCl ionizes in water to produce hydrogen ions. Maybe one extra thing that you can add for this one is free moving ion is present. Okay. Then the other one, HCl does not ionize in organic solvent. No hydrogen ion present. Okay, no free moving ion. And then the last one here will be, I can conduct electricity. And the other one, I cannot conduct electricity. Okay, so that's where you got your 4 marks. 1, 2, 3, 4. 4 marks already here. Okay, the next one will be very similar. Okay, I've got, what's your observation? The first thing that you must start is always observation. Always and always. If the question say, explain the differences in observation. Step 1, explain that difference. What's the observation? First one, I got gas bubble. The other one, I got no change. Next, step 2, explain why that happened. HCl ionize in water to produce hydrogen ions. HCl does not ionize in organic solvent. No, boliao hydrogen ions. Here I can put, okay, I show my acidic property. I cannot show my acidic property. So I've got a few more questions here which you can try. All these questions you can try later. All similar questions. Okay, teacher's going to skip to strong acid, weak acid. Again, this one also I feel that y'all should know. So teacher doesn't want to waste time. Okay, strong acid, weak acid, all of you should know. Let me just see whether I can. Okay, I want y'all to do this question for teacher. This is MRSM question. Okay, teacher give you 2 minutes, answer for me both the questions. Don't worry, whatever teacher skip is because I think I've gone through with you many times already. Okay, and I will pass you the slides later. You still got time to read it. Okay, so what is the basicity of ethanoic acid? I hope no one asked me, teacher, what is basicity? Teacher Peng San already. Okay, what is the basicity of ethanoic acid? Correct. Okay, so basicity is actually, they are just asking you whether it's monoprotic. So all of you write down, see, until last minute also, we are still learning new things, okay? Basicity is monoprotic, diprotic, okay, triprotic. Okay, so ethanoic acid is a monoprotic. Why? Because even though there's a lot of hydrogens in it, but we only look at the hydrogen that is being ionized, which is this hydrogen. Okay, so the question say, state the basicity, you told me is monoprotic. Okay, why? Explain why. I gave you a part of the answer already there. Why is it a monoprotic? Why is sulfuric acid a diprotic?
It produces 1 mole of hydrogen ion.
Okay, very good answer there. but teacher has to complete the answer. Okay, so 1 mole of ethanoic acid ionized in water. So you must have that word, 1 mole of ethanoic acid. Even if you don't have the word 1 mole, is fine. You can put that ethanoic acid ionizes in water. You must have the word ionizes in water, okay, to produce 1 mole of hydrogen ions. Okay, hydrogen ions. All right, good. Okay, next question. Okay, I want to see you all doing this question. 4A last year, which is y'all, my 5A kids. Do you remember doing this experiment or not? This balloon experiment. Ras, do you remember this, Ras? Treshan.
Yes, Chair.
Treshan, are you here? Treshan, do you remember this experiment? If this comes out on in the exam, you all should be the happiest people, okay? All right, so
Sure, teacher.
okay, so here I got glacial. Everybody circle glacial, everybody circle solution. If I have the video, if someone has the video, please send it in the send it in the group again. Okay, one is glacial, one is ethanoic acid solution. Okay, question. Question. Explain the difference in the observation between experiment 1 and experiment 2. When you see these kind of questions, what is the first thing that you must do? What must you explain first? What must you write about first? Observation, correct. What must you do second? Okay, you do your inference, and your last one will be explanation in balloon world already. Okay, now answer this one for teacher. 3 minutes now. Then teacher will go to solve. All trying, yeah, all trying. You can draw a table. Actually, a table will be really nice here. Okay, so teacher will draw a table. You all must try, yeah. If you all don't try, wasting my time, wasting your time. Okay, so let's do the first one. Let's look at experiment 1. Talk about the balloon. What's happened to the balloon in experiment 1 and the balloon in experiment 2? Who would like to try that? Ras and Treshan, maybe y'all can do it because y'all did the experiment the last time.
Chair, can you show the diagram of the balloon?
Can. Okay, before that, yeah, what's the definition? What's the meaning of glacial? Oops. What's the meaning of glacial? No, not necessarily solid form, no. No. Pure, okay. Glacial actually no water. Pure in a sense, lah. Yes. No presence of water whatsoever. Okay, correct. All right. Yes, Ras, okay, what's your answer here? What is happening to the balloon in experiment 1 and experiment 2?
Balloon in experiment 1 does not inflate. Balloon in experiment 2 inflates.
Okay, very good. Does not inflate, balloon inflates. Okay, correct. Okay, good job, Ras. Okay, Treshan, tell me why. So what is the, sorry, go ahead.
Teacher, okay, can I see the table? I mean the drawing, the diagram.
Okay, go ahead.
Oh.
So what's causing the balloon to inflate, class? Are you sure got hydrogen gas? Are you sure got hydrogen gas? I got carbonate here. Oh. Correct.
Carbon dioxide.
Carbon dioxide.
Very good. Okay, so let me just help Treshan here, yeah? Okay. No carbon dioxide gas is released. Okay. So this can actually be a KBAT question, yeah, class? Okay. And here you can actually put carbon dioxide gas is released. Okay, now why in experiment 1 no hydrogen gas is released? Okay, so 3 marks lah. Okay, then we talk about what does glacier do not have? Okay, what is the key point here? What does experiment 2 have that experiment 1 does not have? You must have this in order for an acid reaction to take place.
Water.
Okay, no, not necessarily. Water is just, okay, what in the water? Actually, it's not the water. The water helps to only ionize the vinegar. What happens after that? What in the vinegar is being ionized that I want that so much? Correct. It's your hydrogen ion. If I go back to all my sentences again, okay, you go back to all of this again. Okay, it says hydrogen ion. All the water helps to ionize it as well. Sorry, the hydrogen helps. The water helps to ionize only. Okay, it's ionizing the ethanoic acid. Okay, then you will get hydrogen ions. So my key point here is I want the hydrogen ions. Okay, so hydrogen ions not present. Okay, hydrogen ions are present. Okay, so see, this is how you answer the question. Okay, you want to, if let's say the question had more marks, then you can actually talk about shows acidic properties, does not show its acidic properties. Okay, and that's how you answer them. If the question gives 7, 8 marks, everything that you saw just now ionizes in water, everything, every sentence you must have. Okay, all right, now let's move on. Okay, I want to talk about a few things, okay, in case this comes out. B is acidic or alkaline? Sorry, not B, the bee sting, sorry, yeah. Okay, very good. A bee sting. If you didn't know, please take note today. A bee sting is acidic. Okay. A wasp sting is what? Alkaline, yeah. So they are the opposites. Okay, so you need to know it's different. It's opposite. If you didn't know it now. Okay, so this is a question. The sting of a jellyfish is alkaline. They told you alkaline. It causes pain. Okay, so it wasp also you can use about the same answer as well. Yeah. Okay, what is one substance you can put on your body without causing any further injury? So again lah, vinegar, lime juice. This is a joke carbonated drink. Okay, but they give you 4 marks. Okay, 4 marks is a lot of marks. So you have to explain, okay, why. So you can say it's a weak acid. All that you mentioned is a weak acid and it will not burn the skin. Okay, it will neutralize the alkaline sting, and all of these are, you can get it very easily. Okay, easy to get. Okay, so if it's acidic, what am I going to use? If it's a bee, if it's a bee sting, what can I use?
Toothpaste.
Toothpaste. I wanted to say toothpaste.
Toothpaste. Okay, what else besides toothpaste?
Shower gel.
Okay, you can no, you can use sodium bicarbonate. Okay, a few more other examples, but mainly it will be the ones that teacher has seen before. Will be they use soda bicarbonate. Okay, that is alkaline. That you can use that. Okay, don't say you use urine for jellyfish. All it doesn't work. Minyak gamat, it does not work. Okay, I just want to stress this point here. No matter how difficult the question you see on Wednesday, or whether it's easy or hard, unexpected, expected, remember, if it's justified, if they give you something weird, just explain. You saw the first question I gave you just now in the 2021 marking scheme. The answer sometimes not even related to chemistry. Okay, but you write down the answer, you explain. You write down the answer, you explain. You write down the answer, they explain. No matter what, the answers are not very difficult. The answers can be found sometimes logically as well. So don't be afraid if you see the unexpected. Just hantam, just do, just goreng something. Okay, this is salt. Now, the salt that I want all of y'all to go, when you have time, go and memorize will be soluble salt that is not spam and insoluble salt. Okay, both of them are very easy. Okay, both of them are very, very easy. Teacher will go very quickly. If let's say you want to get magnesium sulfate, okay, it's not an anak salt. Anak salt, you must use titration. This is the one. Don't worry, you will get teacher's slide. If you're looking at it, anak salt, you will get titration. Okay, This one, you are not going to use titration. You have to use a different method. 3 ways to do it. Okay, you can use metal with base. No, sorry. Metal with acid, metal oxide with acid, metal carbonate with acid. Okay, and then you can get magnesium sulfate. Okay, class, if I want to get magnesium sulfate, what acid should I be using? The first one already, teacher took magnesium here, magnesium, magnesium, magnesium. If I want to get a sulfate, what acid I should use?
Sulfuric.
Sorry, Nick, I didn't hear you.
Is it sulfuric?
Correct. You must use sulfuric acid. Okay, let's say teacher change. I want to do magnesium chloride. To prepare magnesium chloride, what acid should I use?
Hydrochloric.
Very good. Okay. And what are the 3 ways? Let's say teacher want to get, I change here. Just want to change for your sake. I want to get zinc chloride. Okay. What are 3 ways that I can get it? Same like how I did above there. What are the 3 ways I can get it? Teacher help you with the first one. The first one will be zinc and hydrochloric acid. Second one? It's here. It's also here. It's also here.
Zinc oxide plus hydrochloric acid.
Correct. Okay, zinc oxide plus hydrochloric acid. Another way?
Zinc carbonate.
Correct. Zinc carbonate plus hydrochloric acid. Okay, these are the chemical properties of this is how you get salt. Okay, so all of this will give you zinc chloride. Okay, what's my side product for the first one? When I have a metal with an acid, what's my side product?
Hydrogen gas.
Hydrogen gas. All this you must know, it must be at your fingertips. So if you really not yet, but it's okay. You still got 2 more days, 1.5 more days is a lot of time. Okay. Teacher's very positive about this. So you should be too. Okay. Many things can happen in this 1.5 days. Okay. When I'm using zinc oxide and hydrochloric acid, what is my side product?
Water.
Okay. And what is my side product here? Whenever you see a carbonate with an acid, you must only get 2 things. What is it?
Water and carbon dioxide.
CO2.
Water and carbon dioxide, correct. Okay, so let me just teach you a simple trick how to memorize this. Okay, since you know you must have an acid, right? You must measure and pour. Okay, I told you A, B, C, measure and pour how much you're using. 50 centimeter cube sulfuric acid into a beaker. Must have the container, must have the measurement, must have the action. Okay, must have the bahan. Then I'm going to heat up the sulfuric acid first. Why must heat up? Because if I don't heat up, the reaction is very, very slow. Okay, then I put in the magnesium powder into the beaker in excess. It must be in excess. Okay, then I'm going to stir the mixture. Okay, and then teacher is going to filter it. Okay, here, Avinash can fly really dangerously. Okay, Avinash is heat. Heat the solution until saturated. Then after that, we are going to cool the salt. After cooling the salt, we filter the salt. And then we rinse it between, rinse it is on top. Between, the rinse is not here, but must have rinse. Rinse the filter paper, rinse the salt with distilled water, and then you dry them between 2 pieces of filter paper. Okay, so they can ask this, okay, soluble salt. They haven't asked this last year. They did not ask this last year. So this is something that you need to take note. Okay, the one that is even more easier for you to do is to get insoluble salt. Okay, you should know this by now. Soluble salt plus soluble salt. I get insoluble salt plus soluble salt. Okay, so let's say teacher want to get silver chloride. What is the first insoluble salt that I must use? Wait, teacher. Okay, you can give me the answer. I hope I've not lost any of you. All of you still here.
I'm here, Chair. I'm here. Silver nitrate, Chair.
All right. Very good. Very good. Okay, so you're going to use silver nitrate. I'm just using, okay, so I want to get silver chloride. My first one, I put Ag plus the second one, teacher put over here. Okay, so what is something that is soluble? Okay, so most of you said silver nitrate, correct. So this is a trick. Anything that is nitrate you put together, it will become soluble. Okay, how do I make chloride soluble? You put spam. Okay, so teacher put spam here. Let's say teacher put sodium here, sodium chloride. Teacher will get AgCl plus NaNO3. Okay, so that is very simple already. You already know this. Just write your sentence. This one is even more easier to goreng. Lagi senang to goreng. It's so simple. Wait, teacher need to stop sharing this one. Pause share. New share. There you go. Okay. All right. So you look at the sentence. Measure and pour 50 silver nitrate solution. Again, they have the volume, they have the molarity into a beaker. In case some of you don't know what teacher is talking, A, B, C. A is my action, measure and pour is the action. B is my bahan. Apakah bahan cikgu guna tu? 0.5 mole per decimeter cube silver nitrate. C tu apa? Container. I put it into a container. Then I take sodium chloride, measure and pour 50 centimeter cube, 0.5 into a beaker. This one is really masak-masak. I love if they ask insoluble salt because it's really masak-masak. I take one solution, pour. I take another solution, pour. Then I stir. And then this one, no need, hippo can fly very dangerously, no need. Straight away, I pour inside. I want to filter it. I rinse it with water and I dry between 2 filter paper. Okay, this is to get insoluble salt. So long they haven't asked how to prepare, yeah? Okay. Teacher wants you to take note about nitrate. The confirmation test for nitrate. Okay, all this is campus. You all have to try and read on your own, but nitrate they like to ask. Okay, so you're going to use dilute sulfuric acid. Then you're going to add iron 2 sulfate and you're going to add concentrated sulfuric acid. Okay, you're going to get a brown drink. Can y'all see whatever teachers? Oh, okay. Thank you for saying. I didn't know that. Wait, Okay, right? Nitrate is very important. They love asking nitrate, but saying that, please don't go and forget the rest. Yeah, you need to still memorize the rest. Here, silver nitrate, Ag plus and Cl minus will give you a white precipitate. Here, Ba2 plus and SO4 2 minus will give you a white precipitate. Here, any acid, okay, you want to test for carbonate, any acid, you will get a white precipitate. Okay, colors also you all should know by now. And I told you something very special. PB, a very special test will be potassium iodide. I'll get a yellow precipitate. Okay. HCl, teacher will get PbCl2. Okay, a white precipitate. Okay, and the last one will be sodium sulfate. Teacher, what is sodium sulfate? I get PbSO4 as well, a white precipitate. So lead is very special. Okay, Pb here is very special. Again, teacher cannot cover everything. There are some questions that you need to try on your own. I've got 2 questions to try with you here. Shall we do it together? All of you look at this salt question. Okay, teacher give you 30 seconds. You try on your own. This is zinc compound. I think there's a mistake here. Zinc compound. You cannot find this question anywhere. You won't be able to find it. None of the states has it. So no one has tried this question before. So your keyword is brown gas. Once you know there's brown gas and you got 3 products, your zinc compound must be what?
Zinc nitrate.
Correct. Okay, it is zinc nitrate. Okay, so it is zinc nitrate. All of you know why is it zinc nitrate, class? Anyone not sure? You can actually PM teacher even if you didn't know. But if you know, just say, I know, teacher, I know. Okay, if those of you who have been here from the beginning and you haven't eaten, please take your food and come and sit in front of this laptop and eat, okay? Because you're not going to leave anytime soon. Maybe another 20 minutes more. Teacher, try to stop in 20 minutes time, okay? Just want to finish salt and a little bit more of chapter 8. So I don't see anyone telling me they don't understand. So I'm assuming everyone understands why teacher gets zinc nitrate here. Okay, teacher got 1 product here, 2 product here, 3 product here. Whenever I got 3,
Explain why zinc nitrate, please.
okay, teacher will explain, yeah? So I've got 1 product, 2 products, 3 products. Whenever I am heating something, okay, look, teacher is heating it and I'm not adding anything inside. And you see the word decompose. Okay, whenever I decompose, it only can be a nitrate or it can be a carbonate. Whenever you see you got 2 products, it's a carbonate. Whenever you got 3 products, it's a nitrate. Even more when you see 3 products and you see the word brown gas. Lagi, you know it's a nitrate because that brown gas is a nitrogen dioxide gas. Leuven, got it?
Yes, sir. Thank you so much, sir.
Okay, all right. So it's correct, number 1. Your zinc powder V or zinc compound V is zinc nitrate, correct. Okay, who can tell me what is my solid M? Very good. Okay, I want to see a little, maybe more people answering as well, so that I'm sure, I hope everybody knows how to do this. So I have John answering. Anyone else? If you don't know how to do, just you can actually send a message to me alone. Teacher, I don't know how to do. But if not, I'm assuming that everybody knows. So I'm wrong to assume that. Does everyone know, or is everyone does not know how to do this? You have to give teacher an indication. Yes? Okay, one says yes. Okay, good. Some says, anyone else? Can I have more responses? Okay, good job. Okay, so teacher will explain, yeah? So, okay, first of all, how did you know it's zinc? Because it's given to me, this is zinc nitrate. Okay, so zinc nitrate, okay, when I decompose, teacher will get 3 products. Okay, memang will get 3 products. Product number 1, or side product number 1, it will be oxygen gas. Side product number 2, it will be nitrogen dioxide gas. Side product number 3 will be a zinc oxide. This is naturally, it will happen. Okay, let me just try so that you understand what teacher is saying. Class, I want all of you to respond together as well, yeah? Magnesium nitrate, if teacher is thermal decomposition, what are my 3 products? Very good. Next, some more. Very good and very good. Okay, I have 1 person sending the message directly to me. Okay, another one is sending directly to me. Can I have the rest of you responding as well?
I am here, sir. I am here.
No, what teacher is saying is answer the question so that teacher will know that you understand what teacher is saying.
Okay, sure. I'll answer.
Okay. Okay, thank you so much. All right, so then teacher move on. Okay, so you already know how to do this. Okay, later the next question they're asking you to write down the equation. Yeah, so what is solid M? So that's why one of your friends answered zinc oxide. Okay, correct, perfect answer. What's my gas P? They very clearly said my gas P is brown. So what's my gas P?
NO2.
Correct. Okay, it is NO2, nitrogen dioxide. Very good. And what is my colorless gas? Oxygen, lah kan? Okay, very good. It is oxygen. Well done. You all are doing very well. What is the color of M when it's hot and when it's cold? So 3 things are very special. We'll do a color of M first, okay? So M is actually zinc oxide, right? So what is the color of M when it's hot?
Yellow.
Correct. Okay. Yellow when it's hot, and then white when it's cold. I can't remember who is this also anyway. I think we changed it so many times. Change the person so many times. Okay. Another one that you must remember is lead oxide. Okay. What color is lead oxide? Oh, it's okay. Okay, John, you are lead oxide. Okay. Sorry, zinc oxide.
John is
Yellow when.
zinc.
Okay. All right. John is yellow when hot, white when cold. Okay, who is lead oxide? Lead 2 oxide. And Ainul got the answer correct. It's brown when it's hot, and it's yellow when it's cold. Correct. Okay, but who was it? Anybody remember? Joshua, the birthday boy. Okay, the last one. I think we all can remember. Copper 2 oxide. What color? It's Yannick.
Black.
It's black in color, but he was quite good. He volunteered himself to be copper 2 oxide. Okay, that's nice. All right, so we got this page right. 5 marks in your hand. Okay, now let's go on to the next question, which is kind of my favorite. Okay, write the chemical equation for the effect of heat and then interpret it in terms of quantitative. Okay, so I'm going to go back just because it's easier there. Okay, so I told you the trick already. Any nitrate, what's your password? When it's undergoing thermal decomposition, what's your password here?
2241.
I had John got the wrong password. Look at John's password. John doesn't remember my birthday. Okay, correct. Okay, so for the 5B who have never heard it before, teacher's birthday is on the 22nd. So it's 22. 2 plus 2 is 4, and there's only one Puan Sheena that you'll ever see in this entire world, hopefully lah. So yeah, that is the way to remember. It works for everything except for potassium and sodium, yeah? Doesn't work for them. Okay, and some of them they don't decompose the same way as well. Okay, so that is your two marks there, chemical equation. Okay, now interpret it for teacher, please. Interpret it in terms of quantitative terms. Quantitative means number. Okay, moments of silence. 2 moles
So am I
of...
supposed to say 2 moles of zinc nitrate
Correct.
produces 2 moles of zinc oxide?
Carry on.
After that, plus along.
And 4 moles of nitrogen dioxide.
4 moles of nitrogen dioxide and 1 mole
1
of
mole of
oxygen.
oxygen. Perfect, correct. Okay, the next one, 7 marks. Okay, the 5 marks one. Okay, let's go back here first. Okay, from zinc compound here, now you know it's zinc nitrate. I added something and I got a white precipitate. What is that? So question is asking you, suggest the solution X and the white precipitate J. So you know it's a white precipitate. You're starting with zinc nitrate. What can it be?
Sure. Is it like related to cation test?
No.
No.
Actually, I think this one can be a lot of things. Can be a lot of things. I think a lot of things possible. A lot of answers are possible here. If you want to use a cation test, you're going to use. But then cation test cannot because don't have excess whatever here. Sodium hydroxide also you must have the word excess. Can I do a double decomposition here?
I think can.
You can. Okay, what zinc will give me a white precipitate?
Zinc carbonate.
Correct. Okay, zinc carbonate will give me a white precipitate. So this is actually a thinking question tau. Teacher, when I first did it also, I've got no marking scheme. This one I'm doing by myself. Okay, have to think for a bit. Okay, so I'm just going to go back so that we can do it together. Okay, stuck. Oops. Okay, so I've got zinc nitrate. Okay, plus, so this is a soluble salt, plus another soluble salt. So we are going to take, let me see, anything carbonate, yeah? So teacher takes something carbonate. Let's say we take sodium carbonate, okay? What am I going to get? Zinc carbonate plus sodium carbonate. What is teacher going to get? My insoluble salt. Have I lost y'all already?
Not sure.
Y'all are still awake, huh? Y'all still know what teacher's doing here, yeah?
Yeah.
Yes.
Okay, so this is actually a tough question. I would say this is a tough question. Okay, they needed you to think about it. Okay, and they didn't give any much hint or whatsoever. Okay, so yes, the answer will be a double decomposition question. Okay, this one you can try on your own. Again, a few more you can try on your own. How to you get a sample of dry, you filter, you rinse, you dry. Okay, here you got zinc oxide and you got copper 2 oxide. You're going to use hydrochloric acid. That's my dog, Joanna. Okay, here HCl, here HCl. Here you are going to get copper chloride, which is blue in color. Here you are going to get zinc chloride, which is colorless. That's how you differentiate them. Okay, teacher gave you the answer because I don't have enough time. Okay, next question. Okay, this one we do together, please. I give you 30 seconds to do. I think after this, quickly. Okay, let's go, let's go, let's go. Okay. 30 seconds, do it first. I think this is a JUJ question, if I'm not mistaken. Yes, it's a JUJ question. Okay, 5B. Here, teacher is heating up something with nothing in it. Okay, and I got 2 products. My salt P must have is what? Carbonate or nitrate? Very good.
Sure, carbonate, right, sir?
Correct. It is carbonate. Well done. Okay. So you have carbonate here. Now they already told you you got magnesium. So therefore, my P will be
Magnesium carbonate.
magnesium carbonate. Okay. Anyone can answer. Yeah. Now we are rushing for time already. So anyone can answer. What's my gas Q?
CO2.
Good.
CO2.
CO2. We are doing fast already. Yeah. Okay. Then my magnesium oxide reacted with nitric acid. What is my salt solution R?
Magnesium nitrate.
Very good. It is magnesium nitrate. Okay, correct. Magnesium nitrate. Sorry if you don't understand my writing. Now, magnesium nitrate plus my salt solution S, I get magnesium carbonate, which is very similar to just now's question. We just did it. Okay, magnesium nitrate plus what? You get magnesium carbonate.
Sodium carbonate.
Sodium carbonate.
Sodium, correct. Sodium carbonate. Okay, see, it's totally similar. You get magnesium carbonate. What's my salt solution T?
Sodium.
Sodium nitrate.
Correct, sodium nitrate. Sorry, teacher's going fast, but I really got no choice. Yeah. Okay, what is my reagent U? If salt come out, you must do salt. Salt is super easy. Okay, salt is really, really nice. You got 6 marks so easily. Okay, what's my reagent U?
Lime water. Lime water.
Lime water, correct. Okay, so 6 marks in your hands. Well done. Okay, now in reaction 2, where's reaction 2? Where are you? Okay, in reaction 2, okay, there you go. Solution Q is added. Okay, I think this one is wrong. I remember cancelling this nonsense. Okay, this is nonsense here. Okay, we see the Malay one. Nyatakan nama bagi tindak balas 2. What is tindak balas 2?
W.
No. Watch properly, watch properly. Here's acid, here's base. What is that?
Neutralization.
Correct, neutralization. So be careful. Neutralization. So be careful, yeah. Is neutralization. Next one. What's the formula for nitric acid? No brainer. Anyone get wrong, I will shoot you. Oi. Okay, yes. HNO3. All right, HNO3, and then move on. What is a chemical test to verify the presence of the anion here? Okay, what's my anion here? Nitrate, right? Okay, let's do this together. Okay, so that, remember I told you nitrate is very important, so I'm quite happy they showed it here. Okay, what's my test? Start with what first?
Dilute sulfuric acid.
Okay, so I'm putting dilute. So if you give me the sentence, add 2 centimeter cube of dilute and sulfuric acid into a test tube, okay, containing salt solution R, okay, containing salt solution R. Full sentence, because the question said describe the chemical test. Okay, that's point number 1. What's my second one? What's my second thing that I'm going to add? Kalau you didn't put into a test tube containing salt solution R, you terus no 1 mark already. Because you put dilute sulfuric acid there, you got no solution R, no reason, no point. What's my second mark? After that,
Add 2 centimeter cube of iron sulfate acid.
okay, add 2 centimeter of iron to sulfate, 0 mark. Adi, is that
Into
you,
test
Adi?
tube. Yes, it's me. It's Adi.
Just now I called you never answer. Where you went?
I was having a nice little nap.
Thank you, Adi. Okay. What's the word missing here?
Into the test tube containing the
Wrong.
mixture.
Iron to sulfate what?
Oh,
Solution.
iron solution.
Yes,
Sorry.
correct. Okay, into the test tube containing the mixture. Sorry, class, this is very short form. Okay, what's my third thing?
Add concentrated sulfuric acid.
Okay, how much?
It's
Concentrated sulfuric acid, how much?
Few
No.
drops.
Okay, a few drops
at
of,
the amount of.
okay, a few drops of concentrated sulfuric acid is added slowly and carefully, okay? Into the test tube containing the mixture. Sorry, you don't understand what I'm writing. Okay, what am I going to get?
Brown ring.
Okay, a brown ring is observed. All right. Okay, yes, it's correct. Correct here. This one you can do your self calculation and which fertilizer is better. Fertilizer, when they want you to answer, you just find the mass of nitrogen over the mass of everything times 100%. Okay, then you can get the answer. Okay. Again, you will have this, yeah. You go and read this yourself. This is so detailed. Teach you how to explain word for word for each factor. You just have to read and memorize. Okay, let's do this together with teacher. Again, you do not have this, only me. Okay, start now. What is the meaning of rate of reaction? Wednesday exam, you know. It's okay, I have faith. 1.5 days, you all can.
Change in the quantity of reactant or product per unit time.
Did you say change?
The change in the quantity of reactant or product
Per unit
per
time,
unit
right?
time. Yeah.
Quantity of reactant or product per unit time. Okay, correct. Okay, if the question say based on the experiment above, okay, based on the experiment above, you cannot answer what Amani just answered. Yeah? You cannot answer like this. You must say change or increase in the you're doing this hydrogen gas, volume of hydrogen gas per unit time. Okay, that's how you need to answer. Okay, so what's my chemical equation here? Very fast, you should be able to give teacher the answer. Zn plus
HNO3.
Okay.
HNO3.
Arrow.
ZnNO3 plus H2. H2. Plus H2.
So not balance. Somebody balance for teacher.
2 HNO3.
Okay, perfect. Okay, well done, Amani and Nick. Okay, this one, so far you all haven't really tried this. I want you all to sketch the graph for teacher against time for 1, 2, and 3. Okay, so let's do this together. Okay, first one, I've got zinc chips, temperature 30. Second one, zinc chips, temperature 40. Here's zinc powder, temperature 40. Start now. All of you try, yeah? I did my answer somewhere. I don't know where I put my answer. It's okay. If you're done, if you don't mind, you can put it in the group so the teacher will know, okay, that you have done. Five A teachers still want you to stay in if until the end. 5B also yes, but I can see some drop off. If you know your friend drop off, especially 5A, I want them back in. If not, they're in big trouble. Okay, so let's draw. Okay, many of you have not drawn before. or not very familiar in drawing, so let's do it together. In case it comes out, you never know. Okay? Okay, so the first thing I must have is a graph like this and two axes here. So here will be volume of hydrogen gas. And then here will be centimeter cube and here will be time. Okay, and in seconds, right? Okay, so very simple, very straightforward. Okay, experiment. Actually, if you calculate, you can actually get the value here. Okay, teacher calculated and I can't remember what was the value just now. Okay, but if you want to know how to calculate, it's very simple. 25 times 0.1, okay, over 1,000. Okay, can someone calculate for teacher? 25 times 0.1 over 1,000, what do you get?
.0025.
Okay, 0.0025 mole. But here, because I'm doing 2 moles of nitric acid to 1 mole of hydrogen gas. Okay, so here 0.0025 moles of nitric acid will give me how many? 125 kan mani?
Yeah, 0.0025. Yeah.
So therefore 0.00125 times 24 will give me the volume. Help teacher Mani?
0.03 decimeter cube.
0.03 decimeter cube, but this one you always must do in centimeter cube. So you times with 1,000, which is 30 centimeter cube. So here, all of them will become 30. Will they all have the same constant volume or will they all be different? Can you tell teacher? Or if you don't know, so you can say you don't know. You don't mind at all, really don't mind.
Same constant volume.
Okay, Amani says same. The rest of you?
Same, sir.
Same, okay, correct. It will all be the same. Why? The reason is because they have the same number of moles here. When you counted MV or 1,000, they're all the same. So we're going to meet up the same. Because I'm just going to draw for you. Okay, so we do, we do 2 and 1 first. 2 and 1, 1 is 40, 1 is 30. So I will do, this is my 1. This is my 2. Okay, and then I want to compare 2 and 3. Okay, 3 I'm using powder, and then 2 I'm using chips. Okay, so oops, 3 will be even faster the rate of reaction. Okay, so 3. You must label them. Okay, and you would have gotten 2 marks here. Actually, should even give you 3 marks because quite good. Okay, now compare the rate of reaction in experiment 1 compared to experiment 2. Should answer, please. Experiment 1 compared to experiment 2.
Rate of reaction of experiment 2 is higher than experiment 1.
Okay, experiment 2 is higher than experiment 1. Okay, explain your answer according to collision theory. If I want to see everybody in both the classes, everything here to be memorized, everything be here to be memorized, everything here to be memorized. Oops, and everything here to be memorized. Both, yeah? All 4. It's just here. All you have to do is memorize it. Okay, so you're talking about temperature. Temperature for experiment 2 is higher than experiment 1. Okay, the kinetic energy of particles in experiment 2 is higher than experiment 1. This one, textbook doesn't, most places always forget this, but you don't, yeah? More particles have energy to overcome the activation energy in experiment 2 compared to experiment 1. The FOC, or even here, you can put FOC also first, okay? Frequency of collision between hydrogen ions and zinc atoms in experiment 2 is higher than experiment 1. The rate of reaction in experiment 2 is higher than experiment 1. Okay, please go and memorize this. Because this is one question. This is an essay question, which, no, it's okay. I don't think that we need to do this. It's here. You want to do, you do. Teacher will give you the answers later. Okay, teacher wants you to go and rest also, and I want you to study chem as well. This is the last bit. What I'll do is I will do with you tomorrow in class when I see you. So teacher will stop here. I don't want to strain you all any further. Okay, 9:30. Just stop sharing stop the recording.